Hi there, my name is Mike Dahlgren. I'm a senior cloud solution architect for Red Hat. And today I want to spend a few minutes talking to you about what is DevOps. And the reason why I want to do that is because it's something that I believe is way overused. And it means something else and something different to each and every person. And so what I'd like to do is take a few minutes to talk about the state of the industry of IT, both from the development and the operations perspective. And then also kind of go into what are the Red Hat tools that are available to help make this world a little bit better. So as we get started here, the first thing I like to do is always drill down a conversation down to the simplest points possible. And really what we start out with is an idea. And then we have a place that we want to put that idea. And the whole conversation that we're going to have is around moving from one to the other. And what are these things? Well, I'm going to call them the what, the where, and the how. And this is important because traditionally, we love the what. We love talking about the stuff. And we like to care about where we put it. What does the infrastructure look like? How is that getting done? These are things that I really enjoy. But really, the important part to talk about is the how. And that's what this conversation is going to be about today. So what is the what? Well, frankly, it's pretty simple. It's just code. That's what we're going to talk about. We can talk about infrastructure as code. We can talk about just code in general, or just ideas. We want to start somewhere, and that's why we're here. That's why we're talking today. But the second thing we want to do is put everything in production. I can't remember who told me this, but I really wish I could. And he said the very worst day for any company is the day that they buy a large piece of software. Think about that. That's a really profound statement. But the point being is software by itself doesn't do anything. It doesn't provide any business value. It just sits there. It's a box on the shelf. And so all that we're going to talk about is we know what the software might be, but how do we move it from one place to another? What does that look like? How does that process work? And so we're going to spend a lot of time going from step by step. How do we get from A to B? And how does our tooling fit in that space to make it better? So first step off the bat. So we start out with code. Most companies have developers building code or having applications. But the very first thing they have to do is actually build that code. Do something with it. And honestly, this is more than just compiling. It's something that you would think that developers writing code for other developers would be easy to do. But it's actually really difficult. And if you look at it and really see how this process works, there's a lot of overhead with it. Now, I was reading that the average developer spends about 2 to 4 hours a week waiting for things to get done. Now, the way they get around that is they actually run multiple things at the same time, which is a good advantage, but it is hard to multitask. But more importantly, there's a lot of complexity around today's builds. So if I want to build a new Java application server, I might have to take that code, compile it, and then start adding in my third-party libraries, add in my custom SQL, database, passwords, usernames, credentials, a lot of hand massaging to make these builds into something that we can actually use. Now, the most important part about that is it's not incremental. And so if a developer kicks off a new build and then they have to change one line of code or maybe update one thing, often this whole process has to start over. And this is a process that even if we do everything right, it can really be hard. In my own personal experience, I accidentally was working on an upstream project for something I won't name. But what I did is I submitted a single pull request up to GitHub, and this pull request had 104 files that it touched. And what we had in the process was perfect. We had all the cloud native tooling. We all had the built-in check-ins, compliance tests, security patching, all that stuff. It's all automated. But the problem was one single pull request that touched all these different files, in actuality, ended up building off the same build process 104 times. And so what I thought was a very simple fix to a small problem ended up shutting down the production build system for about 5 hours. And that upstream open source project wasn't able to get anything done because I was trying to be helpful. So it's important to note that even though we have all the right tooling, we have all the right things, bottlenecks are a big problem, and it's not something that's easily solved. Moving up the chain from building is configuration. And this is interesting because this is really where Linux's wheelhouse is. And it's not a solved problem. I always ask people, if you can name the largest O'Reilly's book ever printed, I believe it's about 1,390 pages, 2.5 pounds, and it's only for send mail. And so you think about it, send mail or email in general is something you want to have on every system in your environment. And you want to make sure it works every time. But what if it doesn't? And how do you have people that can be trained on every piece on that system? If I have 2,000 RPMs and 200,000 files on a server, and I have to configure and manage each and every one of them, that's a real overhead. And so I really love the comics from XKCD, and so I borrowed this one here, but I think it perfectly resembles what the problem is in this situation. And so for the joke, it says, disarm the bomb. Simply enter a valid tar command on your first try. No Googling, you have 10 seconds. And the joke is, clearly they know they're all going to die because you can't know everything. And tar is something that people are familiar and use every day, but even then it's just one of many different packages and pieces that have to be managed separately and have to have that skill set all the times, otherwise it doesn't provide any value. What's interesting though is the state of the union in this area hasn't changed that much in the last 10 years. If I look at the State of the Union today versus in 2007, it looks pretty similar. I would say about 75 to 85% of all the virtual machines out there, or all the systems out there, are virtualized. That's probably pretty fair. It's a bit interesting though, because we're starting to see it go the other way as we start getting big data and more of a commodity scale. But also, typically companies use VM templates to manage this. And templates are great, like don't get me wrong, but they're not a perfect solution. And so, for example, if a person wanted to take a template and make sure it was patched and updated correctly, what does the process look like? Well, typically you take that template, you convert it to a virtual machine, you'd power it on, you would run any patching or checking or tests on it, you would sysprep the machine, you turn it back down, and then you convert it back to a template. This is a pretty manual process, and while this works for a couple templates, it does not work if you have 1,000. And so the question is, how do we work differently than we did before? Because the tooling hasn't changed much in this time, and the overhead adds up every time we do it one additional part. Now, moving right up the stack, the next thing I want to talk about is actually about deploying. We want to push those bits out. And I'm always surprised at how many times I talk to people and ask them about what their deploying system is, because there's a lot of really neat things in this space. We got Ansible, we got Puppet, we got Chef, we have other solutions out there. A lot of things are happening. But I'm always surprised at how many times I talk to companies and ask them what their deployment solution is, and they show me some kind of program where like you type a command into one screen, it actually runs it on 4 screens at the same time. And honestly, they're pretty excited about it. And that blows my mind because really, you're not changing the nature of the game. What they're really doing is painting with a wider brush. You're still painting the fence by hand, but you're doing it with bigger swatches. So it doesn't change how this gets done. It may help efficiency a little bit, but this is not the future. And this is a problem that we typically deal with. Moving down the other side, patching. And honestly, this is something that nobody likes, and nobody likes doing it and doing it well. And it's a little bit scary. I was just reading that they're saying that half of all companies out there do not have a patch process in place. No documented system for doing it. More scary than that is half of the companies that don't patch at all. Once they put a system in place, they consider that golden, and it stays there forever. And even if you have a company that really does get it, a lot of times it doesn't make a lot of sense when you see it in action. And so, for example, I was talking to a very large hospital, and I was asking about their patch process, and they have a process in place, and they do it, and it is scheduled, and it is documented. But once you really look at it, it doesn't make as much sense. And so for their instances, they would have 15 full-time employees doing nothing but patching. Well, I take that back. They would do nothing but patching for 2 months of the year. Every 6 months, they would break out a month at a time into 24-hour segments and go through and patch the systems. And they would deli up the work between the different people. The really amazing part about that, though, is this is just the operating systems. And so you think about how much time is spent just patching the OS, and then realize at the same time they're doing the same thing for the application servers, the database servers, the network equipment. All these different groups have to come together to patch a single system, and this takes a huge amount of time and effort. To make things even more interesting, the way that they find out if they're successful from patching is they would run a script on the server at the very beginning and see what processes and what's actually working on that system. And then they would update the OS, reboot, what have you, and they would run to make the same script again and do a diff and see if the same processes are running after the update as that were there before. Now think about this. Like, it may tell you that the same things were running before and after, But the problem with that is, how do you know if the right things are running? How do you know if the application is working correctly? How do you know that you don't have a rogue process running when you didn't mean to have it there? So the way that the patch process they have in place does this doesn't actually tell you if things are right. And so this is a thing that needs to be solved as well. Finally, the last step in this process, I would say, is verification. And this means a lot of different things to different people. We can be doing more of a compliance thing. We could be a hardening, a STIGs, a FIPS 140, something along that lines. But to me, verification is more than just to make sure that things are compliant and that they work, but also to test them in a real world life scenario. And so in a past life, I did a lot of work with an airline. And what's interesting is, we could take down a mission critical system. We can move it from data centers. We could shut it down one data center, bring it up a couple states away, test it, shut it back down, bring it back over to where we were before. We could possibly do this in a couple hours. And I thought that was pretty good. But this is only one piece in a very larger system. And so what happens is, even though we can do a DR failover for one component, what would happen if we lost a data center? All that testing and all that DR and all that verification doesn't count for anything when we have a real large scale issue. And it also involves DR. I was chatting with somebody from a large credit card company, and I was asking them about their backup strategy. And what they told me is, they said it's in Montana. And I'm like, what does that mean? Like, that's where you have some place for backups? And they say, no, that's where my shanty's going to be when stuff hits the fan. These are not the kind of conversations that you want to have with people that you trust and that you have access to your information. But this is the way IT works today. And it's really a little bit scary, especially when you start seeing how the sausage is made. So what do these things have in common? Well, I would say traditionally, as I talk to different customers and companies, the existing systems out there have three things that they share. Almost all of them use email to coordinate. It means it's a significant manual effort, and the people are the pieces in the process to make these things happen. The other one I'm always surprised by is how much of these things is actually tracked by spreadsheets. I can't tell you how many times that I go into a place and ask them about their point of truth system. Where is the system that keeps track of what is in IT? And what happens is they usually point to a guy named Gary and say, well, Gary manages that system. He keeps the spreadsheets. The problem is Gary doesn't scale. Gary is one person. And even though he might keep the spreadsheets, that's not the way we can keep track of things from going forward. Just because it worked once isn't going to help us necessarily as the next generations come out. The other thing to think about is, as we add up these things together, there's huge costs associated with the way we do things today. And so I was talking to an analytics company in Kansas, and they were actually really interesting. They were telling me, what does this cost from a managed services perspective? And so every time they built out a virtual machine, going through the process that we just went through, is going to cost them about $4,000 from a managed service provider to deliver this service. And so $4,000 may or may not seem like a lot, but the scarier part is, at half the time, they had to manually fix something on that service that was built. So they'd have to touch these things each and every other time that they were done. Another one that's interesting is, it only took them about 2 weeks to go from I have code or a desire to make a new system to one running in production, which is actually really good. I know that I've talked to some companies and they have SLAs of 90 days, and every time it takes them exactly 89 days. And they don't know why, but that's just the way the system's built, and that's the way the managed services works. But let's say we just take our 2 weeks wait and our 4,000 per VM. What does that look like? Well, that's one VM, but what does it look like if we take it times 1,000 VMs? And then the numbers start to really add up and get a little bit scary. So before we had a $4,000, well, now we have $4 million. And not only that, but 500 times do they need to be touched to be fixed in some way. But the part I think is probably the most interesting, and the thing that gets me a little bit scared, is even at 2 weeks wait per 1,000 VMs, if you do the simple math, that's like 38.4 years of waiting. Somebody's whole IT career is literally just sitting there waiting for things to get done. And when we think about why IT costs so much, I think this is really the crux of it. This is where, these steps in the process, because they're not very fluid and they take a long time and cost a lot, they add up at scale. And so what we see when we go through these things is, it's not the what, it is not the where, but the how makes up about 75% of IT spending. And when you realize that this is trillions of dollars, there's a lot of room that we can work in here to make things better. And so now that I've given a real quick overview of how I see the environment, I want to spend just a few minutes going through some of the Red Hat technologies that are out there to help make this world just a little bit better. Now, the first one, and possibly one of the oldest, is Red Hat Satellite. And the thing I really want to mention about Satellite is everybody thinks it's really a patching system, but in reality, fits in all three of these spaces. It's there for configuration, it's there for deployment, and it's there for patching. So it works quite a bit in doing things that are much more than what people use it for. So I'm not going to go into a deep dive into Satellite itself, but I do want to touch on a little bit on what it does and also about some of the changes that came with Satellite 6 versus Satellite 5. So what is it? Well, like we just said before, it's actually four things here, but it's the same three that we talked about before. It's provisioning, it's patch management, it's configuration management, and also monitoring to make sure that this process all works together. The other part that's important is it's a life cycle. This isn't just a one and done. We want to be able to define and deploy our infrastructure. We want to be able to manage it. And we also want to be able to know when it's no longer being needed and be able to retire it automatically or through a process. And so I don't care where these things live. We could be talking about physical machines. We could be talking about hypervisors, mainframes, workstations. I really don't care. But the nice thing is we can all manage it essentially from a standard system, one that we can share across the board. One of the big things that's changed with Satellite 6 over Satellite 5 is kind of the way that scaling works. And so if you're familiar with Satellite 5, it's all about having caching servers. Now you'd have a centralized Satellite 5 server, and then you'd have caching or YUM servers that would share that content out to a wider area. Satellite 6 actually changes that a little bit. And so it's similar in the way that you still have a main Satellite 6 server, but now we have headless nodes that we call capsules. And so you wouldn't want to necessarily log into them directly and manage them directly, but in theory, they can do all the same things that our master server can do. Why do we care about that? Well, sometimes we may want to have different satellite servers distributed to parts of the world, and we want to have latency is a big issue, or bandwidth issues is a big issue. Other times you might want to have a capsule living in a demilitarized zone, a DMZ, or different environments such as stage and production, where you really want to separate them physically and from a logical standpoint, but still not have to manage multiple satellite servers to get things done. In this case, we have a single Satellite 6 box, and we should be able to manage all the other capsules in our environment and our infrastructure from one single place. The bigger change that's happened in Satellite 6 is really one around content promotion. And this is one of those things where more people talk to me about this than anything else, because it really kind of flips things on its head. With a Satellite 5 or a traditional patching, you can patch different environments at different times, and you'd actually develop snowflakes by doing it. And so if I patched my staging environment in October, and I patched my staging or development environment in November, and then my production environment in December, all three of those are going to be at a different patch level. And so it's really hard to say, I'm going to make sure that they're all patched to the same date using just a single point in time. Well, with Satellite 6 is we actually roll up these content and these patches into bundles. And so you can say, I want to have my quarterly patch bundle or my monthly patch bundle, and I'm going to roll that through my different environments as a unit. And so I have my Q1 patch bundle, and I will roll that to my development environment. And once that's done, I'll roll it to my QA environment, and then I'll roll it to my production environment. And what that gets me is at the end of the day, I know that all three of those environments are now patched to the same level, and they all match. And as we all know, it's very hard to keep staging and production identical. And this is one of those things to help make sure that they don't go out of sync from an operating system standpoint, or even a configuration standpoint. I'm not going to spend too much time talking about recipes, but the thing I want to get across is really we want to be able to define our infrastructure as code. And what that means is saying, I don't want to have people log into servers and configure partition tables or set up subnets or do anything like that. I really want to define what that recipe looks like. And once I have that recipe, I want to reuse that multiple times in different environments. And so the idea is I can define this stuff once and reuse it and kick it off and get the builds going and think of physical infrastructure almost like I would as anything else. And Satellite has a lot of things in this space that helps make this happen. Instead of having templates go through and, like we talked about earlier, have to sys prep them and keep them updated, Well, why don't I just define a recipe for what an operating system looks like once, and then every time I deploy it, I know it's going to be patched and updated to the current release or to the correct release. Now, the last thing I'll say about it is it has a full command line and API. And this is really important. And it's kind of it's a subtle change, but I think it's an important one. Because if you look back 10 years ago and ask people what is a good piece of software, traditionally they'd say it has a good UI or good cornflower blue icons or something, that's it's intuitive. And what we found is that's not really a thing that people care about anymore. Because I don't want software that people interact with easily. What I really want is software that talks to other software. How can I automate this? How can I tie this into my rest of my tooling? And how do I ensure people don't ever have to get in there directly and touch buttons to make things happen? And so with Red Hat Satellite and some of the other products, it's been interesting that the idea is, how do we make the command line first? How do we make the API first? How do we do these things? And then once we have them, how do we build a UI around using those tools? That way we know the UI is working the same way as the API, and we also can exercise the API by building out the UI. And so it's kind of a different approach, but I think if you really think about it, would I rather have a software system that works first and looks pretty second, or do I want to have something that looks pretty but doesn't work? I think you understand that, like, where the priorities should be, and I think most people are starting to figure that out. The next thing we're going to talk about is Ansible. And I'll be honest, Ansible is probably one of the most exciting things I've seen in 20 years in IT. The things that I get to see people are doing with it is really amazing. And I'm constantly surprised at like how much is possible, how quickly once people like really start playing with it. So it's a little bit confusing with the other things out there, but when you think Ansible, I really recommend that you think two words. I want to think about action and I want to think about automation. So what I mean by that is I don't want to have consistency. I really want to say, Ansible, go do something. Make this thing happen. And that's where Ansible jumps right in there and takes care of it. How does it do it? Well, a couple different things. I love this quote, and I think it does a perfect job of explaining what Ansible is, by Alan Kay. And really it's saying that simple things should be simple and hard things should be possible. And really that's the best you could hope for, right? And too much of IT today is really having silly, simple things being really tedious and hard. And the question is, how do we get around that? And with this, it's really about having better tooling. How does it do it? Well, honestly, it comes down to three different things. It's simple, it's powerful, and it's agentless. And to me, like, it's interesting when you see it in practice. For simple, it's absolutely human readable. And the best example I've ever been to this is I was actually at a meetup group, and somebody brought me in from another company, and I was showing them how to build out systems in the cloud using Ansible. And the person that brought me in, actually, he raised his hand and said, Mike, I don't know if you know this, but you have a bug in your code. And I said, really? Like, that's interesting. What do you mean? And he said, well, if you look at it, you're going to see that you're not setting an IP address. And like the machines that you're building on this cloud provider, they're not going to get on the internet. And I said, you know what? You're absolutely right. If you look at it, I was trying to get everything to fit on like a size 10 font on a single slide, right? I was trying to like simplify it to the point where anybody in the room could see exactly what's going on. So I was only trying to do it like 7 or 8 lines of code or an Ansible playbook code. But the fact that this person who has never seen this before, seen this YAML code before, automatically knew there's a problem, tells you just how simple it is. Because I can tell you from my past life, if that was up there in Ruby or Python or Puppet or Chef or something other language, I don't think you would have ever seen the problem. But since it was simple enough to put on a single PowerPoint slide and show it to a room, the fact that you can immediately tell what's going on really tells you how powerful the stuff is. Now, about powerful, it's interesting because in my experience, I come from an operational background. And usually from the developers and operations, it's fairly separated and they throw stuff over the wall and then one team has to take it and run with it. But Ansible is pretty unique, and it's the only time in my career I've ever seen a tool where the operations people like it and the developers like it. I've literally never seen that happen before. And it was really hit home because on one day I was out talking to a customer in the morning, a large retailer, and their operations team was using Ansible, and they wanted us to come in there and talk to the development team and try to explain to them why the advantages were. And it's one of those cases where we kind of sit back and just let them talk to each other, you know. But that was fun. And then that afternoon, I went to another company, and their developers were using Ansible, and they're trying to get their operations team to use it. Again, I've never seen that happen before. Usually somebody has to compromise. Somebody has to run the system for somebody else, and one side uses, the other side supports it. In this case, both sides use it great, can use it together, and the more collaboration they do, the more powerful it gets, because they have a shared language to share this with each other. Probably the most important part about it, though, is it's completely agentless. And so it's going to use the same protocols that you'd use today to manage your environment. SSH for Linux, WinRM for Windows. Why is that cool? Well, there's no agents to exploit. There's no overhead of having it. And it's just using the system you already have. Not only that, I would love to see a paper or a documentation on just how many agents most companies actually deploy in production. I really wonder. I'm guessing it's probably between 7 and 9. And if you actually added up the amount of overhead and cost and time that each one of these agents actually takes out of the day, it's got to be substantial. As a thought exercise, I leave it to the user to think about your company and how the different agents actually affect the overall cost and efficiency of your environment. The last thing we want to do is add any more. So I stole this because I'm not a very good artist, but I think it's a fantastic job of explaining how things get done with Ansible. So this actually came from sysadmincast.com. He has a fantastic 4-part series on Ansible. And I think it's beautiful because if you see this diagram, you wouldn't know the difference between me just working on my laptop, my desktop, and managing a web server, or if it's Ansible. It works exactly the same way. But what's really interesting is once you apply stuff with Ansible, you can apply a host inventory, which is literally nothing more than like a Windows INI file style system that lists all the different items in the inventory. And you add that to a playbook to say, here's the machines I want to do something on, and here's the things I want to do. And then it works exactly the same way. Now, in reality, I would not recommend people use it with just an INI file, as a regular inventory file. What you'd want to do is hook this up to your point of truth, and hopefully not to our friend Gary that we talked about earlier. But why is this cool? Because once we have these two things defined, it doesn't matter the scale that we go to. I was talking to one company, and they were touching 50,000 nodes at a time. 50,000 nodes with Ansible, but they were doing it 750 nodes at a time. And I asked them, frankly, I'm like, well, why don't you up that number? I bet we could go even higher. And they're saying, we don't really need to. We're already touching every single system we have in our environment in 15 minutes. We think that's a pretty good place to be. But the interesting part about it is we don't really know what the limitations of Ansible are because all the work is basically done on the worker side, not on the Ansible servers. The Ansible server itself is actually just saying, hey, you guys go do these things. Like a sysadmin was just typing in the keyboard. You go do this, you go take care of this, and then come back to me as soon as you're done. And with that, we can scale to almost any level that we want. And we can do it, exactly the same every time. Now, the results of this have actually been phenomenal. And so I took this screenshot from Google Trends probably about 6 months ago. So it's going to be a little bit outdated by now. But I don't know about you, but I'm not a statistician, but I can kind of see a trend line when I look for it. And frankly, it's just taken off. And I'd love to see how this is today. And so if you know about Google Trends, they're not looking at number of downloads or anything like that. They're really looking for what are people searching for today. And clearly Ansible has been a huge part of that. And I think, if anything, it's only accelerated since that time. So at the beginning, I said I'm going to talk about solving simple things should be simple, but hard things should be possible. And I actually cheated a little bit because I want to show you a couple examples of solving really hard problems simply. And I always challenge people to point to me a better way to do these problems because I've never found it before. In all my years of operations, these things were almost always scary bash scripts that I had to write and maintain, and now I can do them in single one-off commands. Now, in reality, with Ansible, if you're using it in the enterprise, you wouldn't want to run it this way, to be honest. Ansible can be run interactive mode like that we're going to show here, but in reality, most people are going to run it through Ansible towers. They'll give you a single UI and a management system that you can log into, delegate access, delegate permission to controls, and really control what people are doing what and where. But with that said, I do want to show a couple of quick one-line commands that kind of show how these things work behind the scenes. So that way, when you look at the enterprise products, you understand how it's actually getting stuff done. So the very first one on here, removing files from servers. This seems like a really easy thing to do, but it's shockingly hard sometimes. And I can't tell you how many times where I've gone into, I've had to manage, let's say, like 80 JBoss servers, or let's say, doesn't matter, 80 web servers, doesn't matter what it is. And what you'll find out is, let's say 79 of them deployed correctly, but for whatever reason, one of them didn't clear out the cache. And so what you'd actually do is you start checking the website and you find out that like one of the machines is actually returning old data, old stale data. And so the solution is to go in there and clean up the cache, right? Pretty simple stuff. And so what you do is you send junior Linux admin into the production site and say, clean up this directory or this file. And what was a minor caching issue is now a real outage. And so how do we fix that? How do we do that better? Well, with Ansible, we can actually use stuff like the file module and say, hey, Ansible, this path, I don't want it to be there. I don't want this file to be there anymore. I want its state to be absent. And the cool part about that is it's not recursive. I don't have to worry about symlinks or anything else or running RM in the wrong directory. I can just say every time I want this file to be gone. And that way I know exactly what it is. And I can run the same command 100 times, and every time it's not going to mess anything up. It's just going to check to see if that file's there. And if it is, it's going to remove it. Well, that's a fantastic thing to have at the end of any like deployment script or any reboot script that we want to make sure that we clear things out. I mean, this could even be stuff in like C:/temp. I don't care where that lives, but I do want to specify whether or not those things are there after I run this command. Now, the second one is a little bit different because I've probably written the same backup script at least 7 times in my life. And it uses a newfangled new technology called rsync. Nothing here has changed in almost 20 years. And it's amazingly a pain in the butt. Because you think about it, let's say I want to back up my servers using the shell command every night at 3 a.m. And what happens? Well, everything works great. But what if my backup doesn't finish in 24 hours? Next thing you know, I have 2 of these commands running, and I don't know that that's happening. And as an operations person, more often than not, I find out a week later when I got 7 versions of the same program running, and the server's on its knees, and the users are complaining that the things are running slow. Well, the worst part is like I don't want to be told by the users that something's broken, and then to find out that I haven't had a good backup in a week. This is not a great place to be. And so, of course, there's always a person that says, and I've done this many times too, is like they say, well, you can code around this. You say, I have my backup command, I run it every day, but I also have to check to make sure I don't already have the previous command running. If the previous command is already running, don't run the new command, but instead send the administrator an email. Well, what if whatever's making that thing take too long to run, keeping the backup command from completing on time, is also affecting the send mail system? That simple thing that we talked about earlier. How do you program around it? How do you know what you don't know? And so what I can do with Ansible is say, take the exact same backup script that I wrote before, maybe clean out some of the more complicated logic that we just talked about, and run it centrally. And say, Ansible, on the web servers, I want to run this command every day, and I want to run it for 20 hours. And if it does not finish in 20 hours, let me know. And so now every time I run this, I know that it either succeeded or it failed, and I never have a case where it failed and I didn't know about it. And that's where the real power comes in. Now, obviously, like we're just running a command by itself. It doesn't have to be backup. It could be anything. But if I schedule it centrally like this, I really know what I have, and it changes the conversation that I had before. Now, the last use case is a little bit of a cop-out because it could be anything. It's another example of just running arbitrary commands on a remote system. This one's a little bit funny, but it's really handy. So I can actually run Apache control status grep status, and I will see the number of requests per second and number of bytes per second for every web server I run this command against. So if I have my 80 web servers like I talked about before, what if I want to see an outputted list of how many connections each one of the web servers is getting per second and how much traffic they're transmitting? Well, I don't know about you, but like this is fantastic when it comes around running against, trying to troubleshoot load balancer issues or maybe unbalanced loads where like some servers are running harder than other servers. How do you know? Well, before I could log into each server and run this command, well, the Ansible, I can actually use this shell module, which allows me to run commands on this remote servers, but also use things like the pipe and other shell commands that I couldn't use before. And that's where I can just plug this command in, and then I run it once against my 80 servers, and I will get a list of all the servers and the output from this command. It's extremely powerful when you're trying to debug stuff and work with stuff at scale. We see a lot of people do things like that around every kind of day automations where they're like, how do I check my time server is correct? How do I check my clock is right? Anytime we run a command on more than one system, throw it in Ansible first. And we can do this at a whole different scale. The second part around this is really around CloudForms. And I think CloudForms is one of the most, I guess, underrated products out there because it's fantastic, but not a lot of people know about it. I think this is a great thing to complement Ansible because while Ansible is all about getting things done, CloudForms kind of wraps it back around. You can't automate what you can't see, and CloudForms provides that visibility in your environment to see what's there, and Ansible is all about the action to make things happen. It also gives you control, but it also helps kind of wrap the whole life cycle around up. So I presented last year at Summit with another company, and it was interesting because they found out once they put in CloudForms to help automate, the build processes for the development environment, they were spinning up about 500 systems a year. But after 6 months, they found out 80% of them were no longer needed. And so with CloudForms, is we can give those users like a control to create their own systems, their own things that they need, but also give them an end of life and say, hey, you wanted a lab environment, you wanted to test something, you wanted a new VM, you get it for 2 weeks, and in the 2 weeks, you get an email that says, hey, click this button, you get it for another 2 weeks. If not, it's going to get retired, it's going to get archived, and it's going to get recycled eventually. This is huge. I mean, we eat our own dog food here inside of Red Hat all the time, and this is one of those big key parts. Because if I want a demo environment, I want a lab environment, I click a button, I get it for a week. At the end of the week, I would like to think I'm going to go back and clean up after myself, but I know I probably won't. But having something that can actually control not only the creation of something, but the retirement of it is absolutely huge. And so in this company's standpoint, they found out like in the first year, 80% of the systems that they needed didn't need to be there 6 months later. Well, the other thing that you need to do at that point is say, okay, but what about the ones that do need to be there? Well, in that email saying, hey, if this is no longer a testing environment or a demo and it needs to be upgraded to production, click this button, go through this process, and we'll escalate it up to something that can be supported. But this is also in a way of like reducing all the overhead that we talked about, the spreadsheets, the manual checking, so we don't have to do this by hand. So with that said, what is CloudForms? Well, frankly, it's a lot of things. It's unified management, it's self-service like we mentioned, it's operational visibility. The one that I get really excited about, though, is compliance and government. And frankly, the reason why I'm so excited about it is because it's something I hate so much. I've spent a lot of time in a past life working for say a large government contractor. And I can't tell you how many times where you'd spend weeks working away trying to get something built or get your environment just right to have the auditors come out, sit in a little room and pull up this big 3-ring notebook and go through and check things off one at a time. And it's amazing when you think you have every I dotted, every T crossed, and then you find out that your coworker installed some new packages or made a change, and now you're failing an audit, and that conversation is going straight to the CIO. It's a really unfortunate place to be, and there's really no reason for it, because once we have these tools like CloudForms, we can say, this is the way the environment should be. If anybody spins up anything that is not compliant, I should automatically check it, and if it fails, shut it back down, email me, suspend the VM, what have you. But we should never again not know what we don't know. And so once we have these 4 different kind of things that we can do, we really don't care where we do it with. And so CloudForms works with their containers, like Kubernetes with OpenShift, on top of their virtualization platforms, like VMware's virtualization, Hyper-V, Red Hat's enterprise virtualization, public and private clouds. So like our OpenStack environments are supported, AWS, Windows Azure. We want to touch CloudForms and say, hey, you go manage all these same things, and then we manage it all the same way. And so if I build a self-service dialog, I shouldn't care which one of those environments that the thing gets done on. I just want to make sure that I have access to all of it. What does it look like? Well, honestly, it looks pretty good. It's actually something a lot of people don't know is CloudForms actually has 2 different UIs that you can expose to your users. The first one I'm showing here is actually the self-service portal. This is the big rounded corners, cornflower blue icons, all of that. Like, how do we show this off as simply as possible so our IT users so they can just order what they need? The other side is more of an operational UI, and this is for our operations team to really go in there and see all the things that are going on in their environment and really find out what they should be looking at, what they should know. And so maybe I want to see the machines that have been spun up this week. Maybe I want to see, the top CPU consumers, top memory consumers, machines that are failing compliance checks. Anything that I would normally want to report on, I just want to expose it at a high level so that I can know to take action. It's because the only thing worse than reporting is getting like 1,000 reports a day that nobody reads. How do we expose those things to the user in the easiest and quickest way? And that's really something that CloudForms does very well. Another part about that is we can also do things like right sizing. And so I don't know about you, but if you ask your users like, well, how much, if you give them a self-service, self-ordering system, what do you want for a machine? If I order a virtual machine, every single person orders the biggest thing possible. It's like, I want 4 CPUs and 32 gigs of RAM for my little like hello world test box. That's great and all, but you can do that, but it has a real cost associated with it. And so on one hand, what we want to do is expose that cost to the user when they order it. That's actually really powerful. And even if you're not doing a true chargeback showback, just showing people prices up front actually changes behavior. Now, not to tangent too much, but in a past life of mine, I actually worked for a large university, and I was a computer manager for one of the departments. And it was funny because I realized that this department of maybe 100 students was using an entire pallet of printing paper every year. And what that is, it's like 500 reams of 500 pages, like literally a large pallet of paper. And I couldn't figure out why it was so high. And so what I did is I put in a simple print quota and gave every student 1,000 pages a semester. And I only had 3 people bump up against that or ask for more. But the first semester, paper usage went down 80%. And I was kind of blown away by this. And I went and I asked the students, I said, what is going on? Like, why is there such a huge drop? And they said, you realize that you're the very last department on campus not to charge for printing. And at night, we open up the door, we let our friends in, we print out everything. We go nuts here because it's free. And why shouldn't we print out everything? And it seems ridiculous, but I think about it, IT is almost the same thing. If we don't expose the cost to the users, we don't let them know that it costs X amount in this environment or Y amount here, or maybe, one virtualization solution is cheaper than another solution, or 2 CPUs versus 4 CPUs. If they don't see these costs when they ask for it, they're not going to have a way of, doing a correct purchase. And so it changes their behavior. So not only do I want to show that information to my user up front inside of CloudForms, but I also want to go through after the fact and make sure that what they need matches their expectations. And so with right sizing, what we can do is say, hey, if you're looking here on the left, I can see different servers maybe have 4 CPUs allocated, but the CloudForms is saying, you know what, this server has 4 allocated, but it really only needs 1. Why don't we take 3 of them away? It doesn't make any sense for them to be there. Or more importantly, maybe I have 4 CPUs in a box, but it's running 80% full all the time. Let's add another one. Because the only thing worse than actually having things underused is having, an application that's mission critical return a 404 page just because it wasn't sized correctly. Well, instead of having people go in there and manually try to adjust these things, what about just having CloudForms go and say, hey, I'm watching how things are going. I'm going to adjust what those CPU and memory resources look like to help meet what their actual usage is. Another part about it is operational planning. And what I mean about this, and the reason why this is such an important piece, is if we don't know what we need, it's really hard to plan for the future. And so where I see this come up most often is different companies will say, hey, like I have a new project coming down the line, and it's going to take 12 new VMs. And the line of business owner says, okay, operations, can you support this? And if operations says no, we don't have the resources for this new project, who's right? Is it he said, she said, or is it one person's word versus another? Well, without any data, nobody knows. And so the only idea here is to say, well, what if we had data? What if we had a system that already knew our environment and then we can make changes to it and simulate what it would look like after those changes? And so here, if I had 12 new VMs coming in, I could specify what they would look like, plug them into my environment, it would tell me where they would fit. Or if they didn't fit. Because with virtualization, it's not around like, does it fit in the bag or not? It's like, how much do I want to over allocate? How comfortable am I running at 120% utilization of memory? These are different conversations. We need different tools to kind of help have them. Another thing around that, and I'll be honest, I'm sure everybody here, including myself, has filled up a data store at one point. And it doesn't matter if this is just like a test machine or the mission critical database. Once the data store is full, everything stops. And it's a really rough day. And I can tell you that from firsthand. But what I want from an operational standpoint is I don't want to know when something is 80% full, which is nice. What I really want to know is like, when am I 2 weeks from being full? Because the trend line of that, how quickly it's filling up, is way more important to me than its actual capacity. And so with CloudForms, it's going to say, hey, I'm going to watch my data stores and tell me an actual date of when it expects that I'm going to be full. And that's way more important to me from the day-to-day to make sure that we never hit that bar. Now, the last thing I really want to talk about is container management. So containers are awesome, and they're really cool stuff. We're going to talk a little bit more about them in a second. But the important part here is, like with VM sprawl, it changed the way we did IT. Before, we used to be able to walk around a data center and look for that old beige server and ask, what the heck is this thing? And we could tell what was going on. Well, instead of that one machine, now we might have 20 or 30 virtual machines that run on top of it that we have to manage and keep track of. But now with containers, we might have 20 or 30 times increase again. So we're going to have dozens of containers running per VM. And so the scale of these things is absolutely different than where we were just a few years ago, and we can't manage it with the same tools that we had before. So one of the things CloudForms does is it will connect up to all of our OpenShift environments and give us heat maps, give us trend lines, and figure out how are things doing, where are they at. And so at the bottom left, you can see like our heat map, and that should actually grow from left to right as we start using more CPU and memory capacity in our environment. And then maybe at night it shrinks back down. But I don't want to manage it by the per container or per pod. I need to manage it as for my whole infrastructure and make sure that I'm ahead of where things are. Not only that, if I'm going to fill it up, am I ready to burst out somewhere else? What does that look like? Well, with using things like CloudForms, we can actually see that at a glance and also put automation around what do we do in these cases. So we talked about a lot of things today, and honestly, I'm telling you all this so we don't do it. Because really, when we're talking about all the building, configuring, deploying, patching, verification, all the stuff that's going on, there's a lot here. But in reality, there's actually a shortcut. And there's a way that we can skip all of this and go right to the end. And that's with something called like Red Hat OpenShift. And if you're not familiar, like this is the real solution. I want to be able to give my developers, have them like log into my OpenShift environment, give me a Git account or some kind of version control account, say what kind of project they're building, click go, and have that take it through the whole process right to production. I don't want to have anything in between that's going to hold me up or have any manual steps. And so I can use all these other tools for that automation, but why do that when I can actually just use an OpenShift that has the automation built in by default? But what is OpenShift? Well, it's a hard one to talk around, and I know though, because really it's a platform as a service, and I know that's kind of, I guess it's falling out of style, but I think it's an important thing to talk about, because it's hard to talk about in a way because just like this analogy here with the blind man and the elephant, everybody sees the elephant through their own eyes or through their own experiences. And so if you come from an operational standpoint, a development standpoint, or anything in between, when you touch this, the pads, it looks like what you're familiar with. And so with the joke here, right, you see the guy touches the horn of the elephant, I'm sorry, the tusk of the elephant, says it's a spear. The guy touches the side, thinks it's the wall. The guy touches the tail, and thinks it's the rope. They all see different things in it, but really they're seeing different parts of the same whole, which makes it fairly hard to talk about. But really, it's doing all the things that we talked about prior, but it's all rolled up into one elephant, into one piece. And how does it do this? Well, frankly, it uses containers. That's a big part about the solution. And so containers, they're new, they're trendy, they're scary. A lot of people talk about it. But the more you think about it, the more you see how they work, it's one of those things where this is how it should have been. We talked earlier about having 2,000 RPMs and 200,000 files. I don't want that. I want to have just enough OS to get me going, and I want to have just as much of the components I need to make that application run. I don't want any more than that. I want them to be immutable so they can't change, and I want to make it so that people can't mess with them. And so the way the containers work, and the best analogy I've ever heard is it's almost like the old cartoon animated self-shading paintings that they used to do. So somebody would hand paint a background image on a piece of transparency. Then somebody would come along and they'd paint another layer, maybe the foreground, maybe the trees, maybe something else. Next person up above that, they would build like the rabbit or who knows, like whoever the characters are in the cell shading, and they build it up layer by layer. Once they have all their layers built, they look down from the top of the camera, take a picture. That's one scene of film. That's one scene of the cartoon. Containers are pretty similar, so you actually build them up at the same level that you would do like that, but you don't start with an OS, you don't start with a virtual machine. Your base image is really more like just glibc. It's just the libraries you need on top of the kernel to make something happen. From there, you go up like your OS layer, which would be more of those libraries, and then you'd add stuff like Apache or Java, and then you throw your Apache code on top. I'm sorry, your Java code on top, and that's all there is. But the cool part is only the very highest layer, only the very top layer is actually something you can modify. And so all the layers below it, the Java, the Apache, the OS, all that, that's immutable and it gets reused every time you spin up the same thing. Or you spin up a different version of the same thing. So you get incredible density. It also allows you to do things like A/B failovers while using the same system. So I want to deploy a new application, new version of my application code. It builds out my container. And so it has all the different layers up except to that top level. It shares the resources perfectly. And then I can say, here's my A site, my B site. Well, let's try the new version of the site. Go to B. It gets 1% of traffic, then 10% of traffic, 50%. Like it can do the slow failover to it. And at any point, if I don't like what's going on, I can flip back to the previous version without having to respin up a whole environment. What does this look like? Well, it's the full CI/CD, right? So I have a user or developer check something into a repository, like we mentioned before. The magic happens on it, the builds, the testing, the certification. It spits out a container. And once I have that container, I don't care where it lives. I really don't. So it could live in a virtual machine. It could live in physical environments, your personal private cloud, like an OpenStack environment, or public cloud. It's really a common box or framework that allows us to run these workloads anywhere with a really low overhead. What does this allow us to do? Well, really, it's around standardizing our infrastructure. And I'm probably, there's not a lot of stuff that's new under the sun sometimes. And the older hat people probably always remember containers are really very similar to like how the Solaris zones worked back in the day, where I want to have a box in a way that I'm going to run this zone and make sure it can do a certain thing. Now, where containers are really different from zones is the zones were kind of a pain in the butt to move around. With the container, once I build it once, I want to be able to move it to my standardized infrastructure, and I don't really care where that place is. Now it's more of a load balancer question or more of a scaling or scheduling question. But the container should run one place just as well as they run in the other. At the same point, Red Hat has like Atomic Linux to say, you know what, I don't want to have to necessarily have a full RHEL instance to run my containers. I want just enough OS to get that done. And last I checked, I think it was like 70, 80 megs install will get you up and running for a container node, and then OpenShift can use that and take that out for scale. So if I want to spin up 1,000 servers, maybe I just want to put an SSD card in every single server and have that be my node, and that thing doesn't have to get written, I don't have to manage it, and I can go ahead and scale this out to any level I want. I'm not going to talk too much about this, but there is a distinction with OpenShift around it. Like, it's not just containers. There's containers and really a bit more of a metadata because we can have more than one container inside of a pod. So a pod would be more like a group of services that are tied together to get something done, and they're going to be built on top of different containers. And so the reason why I bring this up is I can't tell you how many times I've talked to companies and they say, well, hey, my developer fired up a container on his laptop and now we have containers, right? Like we're at scale. And the answer is no, you're really not. It's almost like saying I started a website on my laptop and we're running a production, but almost worse in a way. So like just because you can fire it up locally, which is great, it helps you build stuff and get stuff ready, the container itself is not the end goal. Like it's really how do I manage it? And so with OpenShift, we roll this all up in pods, we put this into units, and at that point, we can start building out services. And if you actually see what this looks like, it's pretty similar to how traditional infrastructure looks like today. So at the very top, we have a networking routing layer that might go out to the internet. We have a persistent storage on the side. We have a registry that kind of keeps track of things. And then we have our standardized node infrastructure and a master server that's going to kind of help coordinate what's going on. And that's going to keep track of our health and our scaling and our authentication and all the rest. And really, to the end user, they don't care where these things live. They don't care how they work. They don't care how they get to it. And then, like we said before, at the very bottom, we have our service layer, and we can actually show that we don't care where they run. It doesn't matter if it's local infrastructure, virtual machines, or public and private cloud. We just want to be able to run these nodes anywhere that we think that's the best fit. And is this complicated? Honestly, it's pretty simple. If I have my different project here, let's say we'll call it Ruby application, we'll see that it's already it's all built out. It has different layers. So I want to build out let's say my 3-tiered application server, just like I would before, where I have my web servers, my application servers, my database servers. I build those all out in a project. And then instead of having to manage it directly, let OpenShift handle all the scaling. So I don't want to say I have to have 3 web servers and 1 database server. What I want to say is OpenShift. Here's what you do. You can have between, let's say, 4 and 400 web server instances. You manage the number of them based on what the load is, and you take care of the scaling. And that way, we can burst up to about any level that we want without having to be there to manually hold its hand. And so these things will fire up very quickly. They'll fire up almost as quickly as you can fire the app. And so, an app preloaded in memory. So we can just spin up as many instances as we need them, and then we can scale them back down when we don't need them. Well, very simply and very quickly, now I can use my infrastructure at a different level of density than I've ever had before, but also put the power and the control take some of it from operations and give it to our end users and to our project owners who really care about what it looks like at scale. So that's a very good look at OpenShift and why that's the real secret to the future of what the Red Hat solution in infrastructure. And honestly, the reception here has been fantastic. It's just been taken off. But I couldn't give a presentation without mentioning our good old friends like Mode 1 and Mode 2. And I think this does a good job of describing it. So if you see where that line is between Mode 1 and Mode 2, I want to think everything above that line is a Mode 1 conversation. So the first half we talked about, where I'm actually manually going through all these steps of building, configuring, deploying, patching, verification. That's like a legacy Mode 1. You don't see a lot of .com startups go this route. They're mostly like the Mode 2. They don't care about any of that stuff. They want to just use the tools that are available, get their code out there, get it to the end users as fast as possible, iterate 50 times a day, do live patching, live deployments. That's the future, and that's a Mode 2 conversation. That's where they're living right now. At the same time, when we're talking about DevOps, I have 2 different lines here, where if you drew a line between the dev and the ops and say, hey, the code, the building configuration, that's a development thing. Now the deploying, patching, and verification, that's an operations thing. But if you drew a line right to the center there, what you'd see is OpenShift is split right down the middle. It really is a 50-50 between a developer experience and an operation experience. And it's so amazing because it's, again, one of those tools that both sides can agree and really understand what it does and be productive with it today. So that's it. I really appreciate your time today. I hope this is interesting and informative for you. But when somebody asks me what is DevOps, I just tell them this is it. This is where we're at, and this is where we're going. So thank you very much, and have a great day.